So let me solve it. That was the question which I gave last time. So what are the constant thing? If you look at the container very nicely, you will figure out the constant thing. So number one thing which is constant is the volume, because we are interested in this portion only. Right? We are just interested in this portion only. We are not at all interested outside what is happening. But actually the gases are going outside also, isn't it? The gases are moving, free flowing outside. But again, our interest is till here only. Our interest is just till here. So this particular portion which I have shown you here is constant, because we are interested in this whatever the number of moles. So suppose if n naught mole is there, and here suppose some n2 mole came, right? Or you can say n1 mole over here and n2 mole over here. Then how to figure out? So within container, so what will be the situation? You already know PV is equal to nRT. So pressure is constant, obviously, because 1 atm atmospheric pressure is applied. Even here also 1 atm. Right, and volume is constant. This time mole into temperature is constant basically. So the moment I am writing like this, so N1 T1 is equal to N2 T2 guys. N1 T1 is equal to NT T2 means, इसको अगर मैं solve करूँ तो N1 into T1 is equal to N2 into T2. Solve करते हैं इसको. So initial mole container 1 and container 2. I will rename this as some, okay, and not, and this will be N2. इसको N3 कर दे रहा हूँ. So container 1 and 2. Container 1 is this and container 2 is this. So N1 means N naught into temperature. Initial temperature is 27, which in Kelvin will be 300. Will be equal to the final mole, which is N2 into temperature in that container is 127, means 400 Kelvin. Yes or no, guys?
Yes.
So from here it is N2 divided by N naught is equal to 3 by 4. So now the fraction of the molecules which is left inside the container is this only, because this figure represents what? Fraction of molecule. Within container. And that is equal to 3 by 4. Whereas if we'll talk about how much it is escaped, fraction of molecules escaped. Escaped. That will be basically what? How much escaped, my dear? N naught minus N2. Okay, N naught is the initial amount N2 is the left amount, so escaped amount is how much? So this is basically N0 minus N2. And whole divided by N0. So this is the fraction that we have to figure out. So can't we calculate this, guys? Yes or no? So
Yes.
this is nothing but 1 minus N2 upon N0. That means 1 minus 3 by 4. So that will be 1 by 4 part is just escaped from the container. Right? In this way, we used to figure it out. Now moving to the next question, which is based on the graph, guys. Okay. Suppose I have given you suppose I gave you 3 isotherms. Suppose 3 isotherm is given. Isotherm. Temperature, if we will talk about T1, T2 and T3. 3 isotherm means, buddy, isotherm means when temperature is constant. Iso means same. Thermal is related with the temperature. So whenever temperature is constant, guys, the term is said to be isotherm. So basically, this graph is about the variation of the pressure with volume, variation of the pressure with volume at same temperature. Temperature is constant, right? So at 3 different temperature, it is taken. Variation of pressure and volume of the gas. So for a given amount of, the question is, for a given amount of gas, for a given amount of gas, 3 isotherms are drawn. Then find the in fact choose the correct option. Choose the correct option. That's what you have to do. So option A is all 3 are equal. Option B is no. T1 greater than T2 greater than T3. Option C is just reverse of that. And D is none of these. Just pick the right choice, guys.
B, sir.
Think about it.
B.
Which one?
B for Bombay.
B for Bombay. That is the right answer. Okay. Yes, Kritika?
Yes, sir.
Are you solving?
Yes, sir.
Okay.
B, sir.
Okay. Manashwi, what's your answer?
B, sir.
B. Okay. All right. So very simple, guys. Very, very simple. How we are looking at it? So this side pressure, this side volume. Very, very simple. What we are supposed to draw, right? You can draw a line which is parallel to pressure axis like this. And let us assume that volume is V naught. And correspondingly, if you look at this pressure, this pressure right? If we'll talk about the pressures, this is P3, this is P2, this is P1. So obviously we can say that at constant volume, the pressure variation is as follows: P1, P2, and P3. So if it is like that, can't we figure out that PV is equal to nRT at constant volume, and mole is also constant, temperature proportional to P. So higher the pressure for a particular isotherm, higher will be. So this implies that T1 greater than T2 greater than T3. That's how you are supposed to think. Three different isotherm. So equal to होने वाला नहीं है बेटा. So it will be B only. Now let's move to the next. All right. So what is the next case? Suppose if I'm changing the graph. Suppose guys, these are the three curves given to you. And that is again for a given molecule of gas. Okay. Where the number of mole is fixed. What you have to figure out, if suppose it is V1, this is V2, this is V3. All right. Tell me what will be the correct relationship for a given amount of gas. For a given amount of gas, if figure out the correct relationship. Same guys, V1, V2, V3. So what will be the correct answer, guys?
Option B, sir.
B, sir.
Which one?
B.
Okay. So B for Bombay, right?
Yes, sir.
Yes.
V3 is higher than okay. Fine. So in the same way, how we did the last problem. So draw this time an isothermal curve where temperature is T naught. Okay. So if temperature is T naught, clearly the pressure related to that, that means P1, P2 and P3, clearly at same temperature T naught, P1 is greater than P2 is greater than P3. Now as you know, PV is equal to nRT. Guys, for this curve, number of mole R is constant, temperature is also constant. So P is equal to K by V. So this implies that inversely proportional. So V1, V2 and V3 will be the correct answer. So which is simply B. So that's how you are supposed to do. So guys, now we have seen already the different gas laws, and there are a few formulation which, as I told you, that ideal gas formula was not, told at the beginning. Rather, the formula which came was Boyle's, Charles, Avogadro. So by keeping other parameter constant, people are measuring. And now ultimately they combined everything, right? Ultimately they combined everything and they found that PV divided by T is constant for a given amount of gas. So this particular relation, okay, for a given amount of gas. So this particular relation where P1 V1 by T1 is equal to P2 V2 by T2 is there, is known as combined gas equation. This is known as combined gas equation. Right? Okay, everyone. So I have covered all the gas law, guys, and you already know ideal gas equation also, assumption also, everything. Now let's move to certain application related to it. Now, till now, what we have discussed, suppose one of the gases are there inside the container, then what will happen? Right? Suppose just one gas is inside the container. By keeping two values constant, how we are basically approaching the relation between the rest of the two. Now here in this particular case, what I'm going to do, I am having a mixture, I'm having a gas 1, say for example O2. I am having another gas, say for example hydrogen, and this is at a condition of pressure P1, volume V1. This is at a condition P2 and volume V2, and the temperature is fixed. Okay, so what will happen if I am going to mix both of these in this new container whose temperature is also T? So my question will be, what will be the total pressure over here, right? Obviously guys, temperature is not so high that hydrogen and oxygen are reacting. So don't think about H2 plus half O2 forming H2O. Don't think about this, because the temperature for this reaction, temperature requirement is quite high. So I'm not going at that temperature. This is far less than that. So here you have, right, and I am giving you the volume of this container to be V. My question is, find the total pressure. Right, that's what my question is. We are mixing both of them, assuming there is no chemical reaction taking place.
So P1 V1 plus P2 V2 by V.
Okay. So P1 V1 plus P2 V2 by V, that is your answer. I'll wait for other also. Okay, same.
The same.
Okay, that's cool. So very simple, yes, very simple. Very simple, sir. Can I say that whatever the number of mole of oxygen plus whatever the number of mole of hydrogen is there, the sum of these mole will be constant? Yes or no?
Yes.
Okay. So number of mole of oxygen will be how much, my dear? P1 V1 upon RT1. Number of mole of hydrogen will be what? P2 V2 upon RT2. And that will be constant, means inside here. So here oxygen came and here hydrogen came. So here in this container, what will be the pressure? So that we don't know. So I'm taking P as total pressure into volume. So interestingly, both the gases will have same volume. Agreed or not, guys?
Yes.
Both oxygen will also occupy the same volume and hydrogen will also occupy. Agree or not?
Yes, sir.
Yes.
Because many student, what mistake they used to do, they used to think that hydrogen will occupy half of the volume and rest half will be occupied by O2. That is absolutely wrong, guys, because there are huge spaces between two molecules. So from outside, if you'll send any other molecule, that will not be differentiated in terms of space. So both the gases will occupy the entire volume, not partly, okay? Because they are not liquid or they are not solid. So the penetration is allowed. So PT into number of mole of O2, my dear, PT into volume divided by how much? Simply R into T plus. Right. PT into volume upon R into T. Total pressure into volume upon R into T. Is it the correct relation which I have written over here? Or is there some mistake in it?
पीटी नहीं होना चाहिए.
Yeah. So whenever we are saying PT, PT means it is combined pressure of oxygen plus hydrogen. So if it is combined pressure, then it should be number of mole of O2 into RT by V plus number of mole of H2 into RT by V. So basically, and number of mole of O2 plus number of mole of H2 into RT by V. So guys, when you take total pressure, then total mole will be taken. You cannot take separately. So PT likha beta. So that means you are figuring out NT. So total mole will be PT into V divided by RT. So this I wrote twice. That is what the biggest mistake. Because the moment I took PT, so PT into V divided by RT is basically the sum of mole of O2 and H2. So that's why I'm not supposed to write this second time. Because I'm not taking the individual pressure, right? I'm taking the total pressure. So for total pressure, we should get total mole. And what is the total mole? You already know. So this is again, this is nothing but number of mole of oxygen plus number of mole of hydrogen. And this was oxygen. This was hydrogen. And guys, what was the temperature in each container? So that was same. So we need not to worry. ये भी T है. तो अब देखो सब RT left and right से cancel हो जाएगा. So what we'll get? P1 V1 plus P2 V2 divided by V. That will be total pressure. Agreed?
Yes, sir.
Now interestingly, okay, let me give you another question then. So here is the list. Question is, suppose this time what I am doing, I took one of the container like this, rigid container, and then I connected through a very thin, narrow narrow pipe ways. And two container I have taken in such a way that the volume are not equal. So I'll simply compress them. And they are separated by an stopper which is placed in between. So guys, this side, suppose we have oxygen. Suppose here we are having helium. They are all gases in nature. And now if the container size is V and let me write in this way, if it is 2V and it is V and the pressure inside is found to be, right, say for example 2P and this side it is found to be P, temperature T1, this side temperature T2. So this was the situation when the stopper is fixed over here. Now if the stopper is removed, now if the stopper is removed, just a moment guys. So obviously there will be, mixing. Temperature is changed. The final temperature here in both the container is T and T. Now my question is, what is the value of pressure? What is the value of pressure in the left container and in the right container? So find the value of pressure. Simply stopper is removed. That's what the question for you. I hope you understood this. Yes?
Yeah.
So how to continue this? Very simple way. So when you are solving it, one thing you need to understand, because even if your stopper is removed, what will happen? Some of the oxygen will flow here, some of the helium will flow here. That means this side it will be helium plus oxygen. This side also helium plus oxygen. Will they ever stop moving from this side to that side? No, sir. they will keep on moving. क्योंकि move क्यों करता है बेटा? Why anything moves? Because of the pressure difference. Yes or no? अगर मान लो यहाँ पे ऑक्सीजन का pressure is too much this side, and this side suppose it is less. So don't you think that molecule will keep moving from this side to that side? So because of pressure difference only, pressure difference है तो बेटा pressure multiply by area करोगे तो force आ जाएगा, force difference आ जाएगा. And if there is unbalanced force, that means on that side the particle will move. So both the gases, it moves from here to there, it moves from here to there, because this side oxygen's pressure is 0 and this side helium's pressure is 0. So helium इधर से इधर move करेगा, oxygen इधर से इधर move करेगा, and they will stop once the pressure in both the container by each gases are equal. So that means some will also be equal once the pressure on both sides is P and P. That was the very, very important key point. Once the settlement is done, once the equilibrium is attained, then both side pressure will be P. Now the question is over. Because what I am saying, suppose if N1 mole is there, and here N2 mole of the gases are there, then this side some N1 dash mole will be there, and this side some N2 dash mole will be there, which is a total number of mole I am saying. Then one thing we can say that sum of mole of the gas in before opening the stopper and the sum of the mole of the gas after opening the stopper will be same. Sum of the mole will be constant. Agreed or not?
Yeah.
So this N1 dash doesn't says about only oxygen. No, N1 dash is the sum of the mole of helium and oxygen, whichever is present here. So now let us apply, because the good thing about the ideal gas equation is that when you apply PV is equal to nRT, it doesn't ask that which gas is there. You need to tell just mole. Means whichever the gas is there, you can apply this formula. Apply करके देखो, number of mole will be equal to what? PV by RT. You do it on both sides, you will get the correct picture. Like N1 के लिए क्या use करेंगे? 2P into volume 2V divided by RT1. Second container में बेटा P into V upon RT2. I mean, when you are talking about this thing, temperature is same, my dear. So container 1, if you want to write, I am saying this has 1 and this has 2. This side has 1 and this side has 2. So N1 plus N2. Okay. So what are the pressures in each container? So beta P, okay, into volume is 2V upon temperature is T. Other case, pressure P, volume V upon RT. So that's the sum of N1 dash and N2 dash. Both are equal. So guys, temperature is given to you. You can remove the R. You can remove the volume also. So what you got? 4P divided by T1 plus P divided by T2 whole multiplied by T is equal to 3P. Agreed? So from here the pressure is equal to, guys, just a second, because I asked the value. So this was an unknown pressure, so it would be better to differentiate. This is 2P naught, this is P naught. This is P and P, right? So otherwise both side PP is appearing, so same symbol is not good. So you can take naught naught and this side P. Here naught and naught. And this side PP, which we don't know. Right, so P is equal to 4P not, wait a minute. So simply P is equal to, yes, 4P naught upon T1 plus P naught upon T2 multiply by T and whole divided by 3. That will be the right answer. Understood, guys, or not? Did you understand this? So what I did, a very simple thing, I simply conserved the mole on both sides. And thereafter, whatever the equation tells, ideal gas equation, I simply followed it. That was the thing which I repeated. So guys, please understand one very good relation will always be there. Ideal gas, how wisely you are applying, it's up to you. How nice you can use.